Today we're looking at lesson 1-7, which is three-dimensional figures for geometry. So here's a picture of some of the what we call solids, and these are considered three-dimensional. So three-dimensional figures, you can notice, are labeled with an edge, a vertices, or vertex. Vertices would be more than one vertex, or a face. So sometimes the solid has just bases, sometimes the solid has a base and a vertex, sometimes it has no faces or edges or vertices. And they showed you the different types of polyhedrons here, which are the prism, the pyramid, and then we have different types of prisms and pyramids down here at the bottom based on their bases. So if it's a triangular base, it's going to be a triangular prism. If it's a rectangular base, same thing. A pentagon base, pentagonal prism. And then you can also do the same thing with a triangular pyramid, a rectangular pyramid, and a pentagonal pyramid. Again, if the base is that shape, then it's called the pyramid. I'm sorry, I might have said the base for the other ones, but if it's a prism, it's going to be the edges that are in that shape, usually, along with sometimes the base. But we'll look at what is a polyhedron and what is not a polyhedron. A polyhedron, each surface on the polyhedron has to be a polygon, and if it's not a polyhedron, it means it probably has some kind of circular base or a curved edge, or it has no faces, edges, or vertices like a sphere. So these three would be not polyhedrons, and then at the bottom there I've already talked about the types of prisms and pyramids. So we're going to determine here whether each solid is a polyhedron, and then identify what type of solid it is. And if it is a polyhedron, we're going to name the bases, faces, edges, and vertices. So if we look at this example, this is a cone, and a cone has curved edges. So we're going to say, no, this isn't a polyhedron. It's a cone. And the next one, we're looking at what type of bases it has. It doesn't have any curved edges. It does have bases, faces, edges, vertices, all of those things. So we just need to figure out it is a polyhedron, but we need to figure out what type of polyhedron, whether it's a prism or a pyramid. A prism usually has more than just bases. It has usually more than one base. So in this case, we have two triangular bases here, if you look at the edges here. So that is going to be a triangular prism. And now we need to start naming all the parts. So if we're going to name the bases, those are going to be the triangular shapes. So we're going to name them with a triangular figure in front of the three letters. So we have triangle GHI, and then triangle JKL. And these are considered the bases. And again, with a prism, the bases are usually the shape of what the prism is called. So those are the bases. Then you have all the faces, which are basically every other flat surface besides the two bases. So we have the two rectangles on the sides of the prism, and then the bottom rectangle to name here. So we put a little rectangle symbol. We have IHKL, that's one side. We have GJKH, that's another side. And then the bottom, GILJ. And these are all considered the faces. basically the other flat surfaces besides the bases. Now the edges are considered the segments or the lines that make up each side of the base and the face. So the edges are going to be written as segments. So we need to list all of them. We have KL, LI, IG, HI, HG, GJ, JK. We did KL, JL. And I'm just looking to see if we missed anything. And it looks like we've gotten all of the sides. So these are considered the edges. And then finally, we're going to list the vertices, which are the points. So basically each capital letter. So J, K, L, H, I, and G. And these are all considered the vertices. So now we've listed all the parts of this figure. The next part, we're going to get a little bit more specific, and we have what's called the Platonic solids, and you'll actually do a project on this a little bit later on in the year where we find the surface area and volume of these types of solids. So they are a little bit more specific in terms of their shapes. So you can see that a tetrahedron is going to have 4 equilateral triangular shapes, and those are going to be the faces. A hexahedron or a cube, which we know very well, is 6 square faces. And basically what makes all these Platonic solids or stand out is they are regular polyhedrons, which means that all of their edges are congruent and all of their parts basically are congruent. So that's why we call them regular. But we're going to focus more on just the surface area of prisms and pyramids, and then sometimes some of these ones that are not polyhedrons, like cylinders, cones, and spheres, but are solids. So we're going to find the surface area and volume of each solid to the nearest tenth. So we're going to go back to our table to refer here, but this is a cylinder, and the volume of a cylinder, if we go back, is right here, pi r squared h, and h is going to be your height, r is going to be your radius. So pi times 6 squared times 18 gives us our answer. So we get 18 times 36, which gives us 648. Since this is going to be finding volume, we're going to label it with feet cubed. Now our surface area, we need to get the formula for. That's going to be 2 pi RH plus 2 pi r squared. And these are located in your key concepts packet, but you do need to know how to use them. So this is going to be, again, plugging in the parts, and then we'll solve. So we have 2 pi times 6 times 18 plus 2 times pi times 6 squared. And order of operations is always important here. So we're going to follow the order of operations by multiplying everything first and doing your exponents there on the right. So we have 2 times pi times 6 times 18 gives us on one part 678.24 plus 2 times pi, I'm using 3.14 as pi, times 36 gives me 226.08. If we add that up, we get 904, and it says round to the nearest tenth, so 904.3 is what we get. It's 3.2, so 904.3, and we label that as feet squared for area. Here we have a prism, and this is a rectangular prism, so our surface area is going to be PH plus 2B, and our volume is going to just be B times H. So we need to figure out what these mean. P is the perimeter of the base, or capital P is the perimeter of the base. So that makes, if we label all these sides of the base, these two are going to be 5.2, these two are going to be 10. If we add all that up, we get 10.4 plus 20, or 30.4. That's our perimeter of our base. Our height is just our h, so 6, plus 2 times a capital B, and the capital B is the area of the base. So 10 times 5.2, which gives us 52. And then we again use order of operations, so multiplication comes before addition. So we get 104 plus 30.4 times 6, which is 182.4. And our total then would be 286.4. And we label this centimeters squared for area. And then the other volume formula over here, we have another big B, which is the area of the base. We already found what that is in the last problem, so that's 52 times our height, 6. So 52 times 6 gives us 312. And we're going to label this, since it's volume, centimeters cubed. So 312 centimeters cubed. The last one we're going to do is the cone, so volume and surface area of a cone. The cone, the surface area is pi r L plus pi r squared, and the volume is 1/3 pi r squared h. So again, we're going to fill in the parts here. So pi, I always use pi as 3.14 times r, our radius, which is 15. Now L, the fancy L here, represents the slant height, which is going to be 17, not the regular height. And then we do again plus pi, and then r squared, so 15 squared. So we multiply first. We do 3.14 times 15 times 17, 800.7, and we're going to add that to pi times 15 squared, which is 706.5, and if we add that together, we get 1507.2. And that's going to give us our surface area, so inches squared for area. And then 1/3 pi r squared h is our volume, so we'll fill that in with our parts. So 1/3 pi r is 15 squared, and height, h is the up and down height, or the vertical height, not the slant height. So we put in 8. And we multiply this, we have 15 squared, which is 225, and we're going to multiply everything together now. So 225 times 8 times pi times 1/3, or you could do divided by 3. which is 1884. And we label volume with cubed, so inches cubed. And as always, we don't shy away here of the word problems. So here we have a word problem, but mainly it's asking us to find, again, surface area and volume, just in a backwards way. But this is saying Jessica is making spherical candles, so we need to pay attention to the fact that it says spherical, because that tells us the shape, using a mold that is 10 centimeters in diameter, so it gives us a diameter there. And we need to find each measure to the nearest tenth. So we need to find the volume of the wax needed to fill the mold, so that means the volume of a sphere. And if we refer back to our chart, the volume of a sphere is 4/3 pi r cubed. Now, we don't know r, but we know diameter, and r is half of the diameter, or radius is half of the diameter. So if the diameter, if we go back, is 10 centimeters, we're going to plug in r as 5. So 5 cubed. We do order of operations, which is exponents first. That gives us 275. And that we're going to multiply by pi. Gives us 863.5. And then we multiply by 4/3. But really, when you do this type of problem in the calculator, I would do 863.5 times 4, and then divide by 3. So that gives us about 1151.3. And we're going to label that with volume, so it said centimeters, I believe, yep, centimeters cubed. So we need 1,151.3 centimeters cubed for the volume. And for the surface area, we need the surface area formula of a sphere, which is 4 pi r squared. Again, if we do half of the radius, which is 5, we're going to do 4 pi times 5 squared, or 25, or 100 pi. 100 times pi gives us 314. And that we're going to label with centimeters squared. Now, I realized when I looked back at my work here that 5 cubed is not 275, so I'm going to just fix this real quick. This is actually 125, so it changes my answer a little bit. Let's see what happens if you mess up one number. You can get the wrong answer. So I'm just showing you that it can happen to anybody, but you have 125 now times pi, which is 392.5. And then we're going to multiply that times 4 and divide by 3. So that gives us about 523.3 instead. And that concludes our lesson on three-dimensional figures.